So just like from the previous video, let's find out more on the last question, just a little refresher. So expressions that have the same value are equivalent expressions. Numerical expressions such as 8 plus 2, 15 minus 5, 40 divided by 4, and 2 times 5 are all equivalent. They are all equal to 10. Take a look at the following algebraic expressions. They're all equivalent. We did that in the previous video. Expression 1, x plus y plus x plus y plus x plus y plus x plus y. Expression 2, 4x plus 4y. And expression 3, x plus y times 4. To show that expression 1 is equal to expression 2, you can use the commutative and associative property of addition to group and change the order of the terms. And they showed it to you down here. Okay, x plus y plus x plus y plus x plus y plus x plus y equals x plus x plus x plus x, because these are all like terms, plus y plus y plus y plus y, these are all like terms, and then you get 4x plus 4y. To show that expression 2 is equal to expression 3, you can use the distributive property to factor 4 from both terms of the expression. Remember, we talked about that last time. 4 is on both terms, so you can take that out, and then you got x plus y times 4. Remember, 4 times x and then 4 times y will give us 4x plus 4y. You can also evaluate these expressions to see if they're equivalent. If you know that a bag of pretzels costs $2 and a drink costs $3, like we did before, you can substitute 2 for x and 3 for y into each of the three expressions above. Okay, there's the expressions. They substitute 2 plus 3 plus 2 plus 3 plus 2 plus 3 plus 2 plus 3 equals 20. We did that last time. And again, they substitute 2 for x and 3 for y. 4 times 2 is 8. Plus 4 times 3 is 12 equals 20. Remember, order of operations. And then the last one, 2 plus 3 is 5. Times 4, you got 20. So the expressions all have a value of 20. Let's reflect on what we just learned and see if you can write two other expressions equivalent to 4x plus 4y and explain your thinking. So I will pause that video and then we will give you an example of an answer, because there could be multiple answers here. So the possible answers that we got was 2x plus 2y times 2, because 2 is a factor of both 4x and 4y. So 2x plus 2x plus 2y plus 2y, because 4x equals 2x plus 2x and 4y equals 2y plus 2y. Let's do that out so you guys can see that a little bit clearer by using the distributive property. You got 2 and then you got 2x plus 2y. Okay, so 2 times 2x is 4x, and 2, well, positive times positive is positive, and then 2 times 2y equals 4y. There it is. Alright, and then they said that 2x plus 2x equals 4x, and 2y plus 2y equals 4y. So there it is. So this is just an example. Let's read the problem below, then explore different ways to write equivalent expressions for the perimeter of a square. The length of a side of a square is c minus 9. 3 students wrote 3 different expressions for the perimeter of the square. Are the expressions equivalent? Explain why and why not. So let's model it first and look at that. Miguel wrote the perimeter as the sum of the 4 equal side lengths, c minus 9. Right? The side of a square. c minus 9, c minus 9, c minus 9. And the perimeter, if you recall, perimeter is adding all the sides of this square. And here they did that. C minus 9 plus C minus 9 plus C minus 9 plus C minus 9. Jessica rearranged the terms, putting the like terms together. So again, she drew the figure, okay, and then she wrote C plus C plus C plus C minus 9 minus 9 minus 9 minus 9. Petria multiplied the number of sides by the length of a side. So she did C minus 9 times 4. Now, you will use the properties of operations to decide whether or not the expressions are equivalent. So let's look at these 5 problems. Look at Miguel's expression and Jessica's expressions. What is the same and what is different about them? Simplify Miguel's expression. Simplify Jessica's expression. Are the expressions equivalent? Use the distributive property to rewrite Petria's expressions. Excuse me for that. Is Petria's expression equivalent to the other 2? Can you think of another way to show that all 3 expressions are equivalent? How can you use properties of operations to decide whether or not expressions are equivalent? So, I would pause this video, I would answer these 5 questions, and then check your answers once you unpause the video. Question 2. Again, what is the same and what is different about both of those expressions? Well, the terms are the same, but the way they are grouped and the order of the terms is different. But all the terms are the same. They got the c and they got the -9. Let's simplify Miguel's expression. When you did that, you should get 4c minus 36. Let's look at this right here so we can help you. 1c plus 1c. Don't let that negative distract you. Remember, that's for -9. So 1c plus 1c is 2c, plus 3c is 4. Plus 1c is 3c, plus another c. We have 4c. -9 plus -9 is -18. -18 plus -9 is -27, and -27 plus -9 is -36. And that's why the answer is 4c minus 36 for Miguel. Now let's look at Jessica's expression. She got the same thing, 4c minus 36. Let's check that out. She just took all the like terms and put them together. 1 plus 1 plus 1 plus 1 is 4c. And then -9 minus 9 minus 9 minus 9 is -36. Excellent. So they are the same, as you can see right here. Yes, they are the same. For question 4, it says use the distributive property to rewrite Petria's expression, and hopefully this is what you got. Remember, 4 times c is 4c. 4 times -9 is -36. There it is. Petria's expression equivalent to the other 2? Yes, it is. Question 5. Can you think of another way to show that all 3 expressions are equivalent? Well, I could replace c with a number such as 12 and evaluate each expression to see if the value of all 3 expressions is the same. So you can obviously plug in any value. They plugged in 12, and when you plug it in, you would see that all expressions will be the same before you even simplify them. How can you use properties of operations to decide whether or not expressions are equivalent? Well, if I can start with one of the expressions and apply the properties of operations correctly to make the other expressions, then the expressions are equivalent. Okay. Now I'm going to ask you to see if you can solve these 2 questions, to try it on your own. Use what you just learned about equivalent expressions to solve these problems. Show your work on a separate sheet of paper, or this one obviously. The perimeter of a square is given as 12x plus 20. Remember to always draw the picture when needed. Write 2 different expressions to represent its perimeter. Use factoring for one way. And we'll go over that distributive property. Question 8. Write 2 different expressions equivalent to 8d minus 4. And again, use factoring for one way. So pause this video and then check your answer when you unpause. So for question 7, you should have gotten something like this. 3x plus 5 times 4, or 6x plus 10 times 2. Another way is saying 3x plus 5 plus 3x plus 5 plus 3x plus 5 plus 3x plus 5. Okay, or you can say 6x plus 10 plus 6x plus 10, or any other expressions equivalent to 12x plus 20. Let's look at the factoring one, because this is where a lot of students still struggle. So watch this. I'm just going to break this down for you. 12x plus 20. The way you factor it, you got to find out. Usually I do what's the greatest common factor between 12 and 20. Okay? In this case, it will be 4. So the greatest common factor between 12 and 20 is 4. So 4 is going to be on the outside of the parentheses. And then you got to ask yourself, 4 times what will give me 12x, positive 12x? So the answer is 3x. And then 4 times what will give me positive 20? And the answer will be positive 5. There it is. So it's 3x plus 5 times 4. And always double check your work. 4 times 3, x is 12x. And then 4 times 5 will give me 20. So that's one way of factoring it. Okay? Think about the word factoring. And then the other ones, obviously, there's multiple ways of writing it, but they did 3x plus 3x, which is 6x plus 3x. 9x plus 3x is 12x. Plus 5 plus 5 plus 5 plus 5. All I'm doing is adding like terms. Okay. Question 8. Write 2 different expressions equivalent to 8d minus 4. I want you to think for a sec. I'm just going to do this out for a sec real quick. What's the greatest common factor between 8 and 4? Can't be 8, because 8 doesn't go into 4. But if you said 4, you are correct. Now think. 4 times what is 8d? 4 times what is 4? Okay, let's see what they got for an answer. 2d, 2d minus 1. 2d minus 1 times 4. Or they did 4d minus 2 times 2. Think, because 2 goes into 8 and 4. It's not the greatest common factor, but it also works. Okay? Same thing up here. Another way to write it is 2d minus 1 plus 2d minus 1 plus 2d minus 1 plus 2d minus 1. 2d plus 2d plus 2d plus 2d is 8d. Negative 1 plus negative 1 plus negative 1 plus negative 1 is negative 4. And there's other ways of writing this.